Welcome to today's video. Today we are going to discuss about homogeneous differential equation. A differential equation of this form, dy dx is equal to function of x comma y over function of x of phi comma y. It's called an homogeneous differential equation if each term of the function given above constituting the terms of x and y and phi constituting the terms of x and y has got the same degree. The same degree means they have got the same powers. For example, dy over dx is equal to 3xy plus y squared over 3x squared plus xy. You can see that the numerator and the denominator have got the same power. Let's say, for example, like 3x squared and y squared. You see, the variable x has got a power of 2 and the variable y has got a power of 2, as opposed to xy in the numerator and xy in the denominator. So in such a case, we put y is equal to vx and dy dx is equal to v plus x dv dx. The reduced equation involves v and x only. The new equation can be solved by variable separable method. Now, the order of business, for example, if you've been given an equation to solve, the working rule, the step-by-step procedure that you're going to use to solve such kind of an equation is that number one, you're going to put y is equal to vx, so that dy over dx is equal to v plus x dv dx. Then step number two is to separate the variables. Then after separating the variables, by separating the variables, we mean that separating the v's and the x after substituting the given constant above. After that, you integrate both sides, then you put the value of v, which is y over x, and then simplify. So in our today's example, x squared plus y squared dy is equal to x plus y dx. So solution. You're going to let y is equal to vx and dy over dx is equal to v plus x dv over dx. So you're going to say that x squared plus y squared, we have, as you have said, we are going to replace the value of y with vx. So we're going to have vx into squared, close the bracket, dy is equal to x, y we have as vx dx. So x squared plus x squared v dy is equal to x squared v dx. So x squared into 1 plus v dy is equal to x squared v dx. So you divide all through by x squared, x cancels x squared. So we are going to have 1 plus v dy is equal to v dx. Now, dy over dx, now dividing all through by dx, you're going to have v over 1 plus v. Now, you're going to substitute the value of dy dx by v plus x dv over dx. Now, x plus x dv over dx is equal to v plus 1 plus v. After that, you're going to divide all through by 1, not all through by v is v over 1. So when v crosses the equal sign, you're going to have a minus. So you're going to have x dv over dx is equal to v plus 1 plus v minus v over 1. Right? Then from here, you're going to divide all through by 1 over dv times 1 over dv. So dv cancels dv. Then you're going to have 1x over dx is equal to v over 1 plus v minus v over 1 times 1 over dv. So from here you can get an inverse or the reciprocal of dv dx over x, which you are going to have x over 1 over x dx. Then on this other part, what you're going to do, you're going to divide, we're going to multiply or open the bracket by 1 over dv. So v over 1 plus v times 1 over dv minus v over dv. So if you get the inverse of this function and the inverse of this function, you're going to have 1 over x dx is equal to 1 plus v over v dv minus 1 over v dv. Then you have 1 over x dx is equal to 1 plus v over v minus 1 over v. Then you factor out the dv. Now from there we have 1 over x dx is equal to 1 over v plus v over v minus 1 over v dv. So 1 over v cancels 1 over v, then v over v is 1, so 1 over x dx is equal to 1 dv. So after reaching at this particular point, you've seen that the x's and the v's have been separated respectively. Now you integrate both parties. You integrate this part with respect to x and to integrate that part with respect to v. And as you know, the rule of calculus, by integrating means you add. So while integrating one, it's going to become a v variable. Then by integrating 1 over x, it's going to become a natural log of x, or an Neperian logarithm of x with respect to x. So you're going to either, you can write natural log ln or log. So in my case, I'm going to write natural log of x plus arbitrary constant c. So this integration is not defined, so it is indefinite integral. So in the rule of calculus, while integrating indefinite integral, you add an arbitrary constant c because there are no limits given. So integration done, you replace the value of v with, as a recap, we say that y is equal to vx. So v is equal to y over x. So you replace that value of v on this other part. So you're going to have y over x natural log of x plus c. Then after replacing the value of y, then you make y subject of the formula. So you're going to have y is equal to x into natural log of x plus c. This is now the general solution. If in a scenario whereby you've been told to find the particular solution, what you're going to do, you are always being given the boundary conditions. So you replace the boundary conditions for x and y, then you get the arbitrary constant. After getting the arbitrary constant, you replace it back to the general solution to get the particular solution. Thank you so much for watching my video. I'll see you next time.